This is 4.4, solving rational expressions. So we're actually solving today. Here's your essential question. How do you solve rational expression? Or rational equations. We have a rational equation contains one or more rational expressions. To solve rational equations, we want to clear the fractions first, then solve like a regular equation. So you don't have to clear the fractions. You can solve using what we'll talk about in a little bit, clearing both sides and all this stuff and combining, and you can do that, okay? You can use the simplifying techniques, finding a common denominator, and all that. But if you don't do that, life is so much better, okay? So is the equation a proportion? If yes, now we're not going to do that. Cross that out. If you have ever heard of cross multiply, I despise it. So a proportion is one fraction equaling one fraction. Okay. If yes, then multiply both sides by the LCD, or a common denominator. I'll just call it LCD. Okay. So to solve these, really the only way to solve these is to get rid of the fraction, okay, eventually. So we have to get rid of the fraction eventually. That's why I say lots of times it's just easier to get rid of the fraction right away instead of you taking all of these steps to go through things. So right here, we need to find the least common denominator, and we're going to multiply both sides by it and simplify and deal with it. So we look at our denominators. It doesn't matter that there's an equal sign separating. We just look at all of the denominators across the entire thing. So x plus 2 and 4. There's no way to turn them into that. So I'm going to use a least common denominator. I should actually label it. Least common denominator of 4 times x plus 2. That combined is it, because we can't turn one into another. There's no way to turn 4 into x plus 2. Okay, so you could technically multiply this one top and bottom by x plus 2, this one top and bottom by 4. Now that they have a common denominator, set the tops equal to each other, that works. Okay, but a lot of people start getting confused of what to do with the denominators and stuff. So what we're going to do is we're going to multiply both sides by the same thing. Okay, once again, since it's an equation has this equal sign. Because of that, we have a nice cool thing that as long as we do the same thing to both sides, we will change the look but not the value. It's very, very similar. It's actually the same property that relates to when we multiply a fraction, the top and the bottom the same, it will change the look, not the value. So in equation, we just have to do the same thing to both sides. If I do something to one, I have to do the same to the other. So what I'm going to do is I'm going to take this LCD, and instead of turning everything into that LCD, I'm going to multiply both sides by that LCD over 1. And you'll notice something really important that makes this much more simple to solve. If I ignore the right side of the equation now, just looking at this side right here, we know, since it's multiplication, anything on top that is the same factor as something on bottom simplifies. So in the end, I get 4 times x plus 7, which we have to distribute. Please don't forget the distributive property. 4x minus 28 equals this side. The 4's simplify. I guess you could distribute a 1, but it ends up as x plus 2. I don't know about you, but this original equation looked crazy and scary. This, by just multiplying by this LCD we found, is not crazy and scary, okay? I have a simple algebraic equation. I need to get the x's all on the same side and the numbers on the other side. So I'm going to subtract x from both sides, and I'm going to add 28 to both sides. So I end up with, so these simplify, 4x minus 1x is 3x equals, and this one is 2 plus 28 is 30. Then I divide by 3, and I get my solution, x equals 10. Okay, but there's a caveat. There's something that we always have to check. So I'm going to erase some of my work here just to make things clear. There's something we always have to check, and we talked about it in the first objective to introduce it, and that is our excluded values. So the 4 can never turn into a 0, but the x plus 2 can. So we look at our denominators, and we say, well, x plus 2 cannot equal 0. So that means x cannot equal -2, and that is something we have to always check. In this case, my x value was 10, so that's okay. If my x value is -2, I would cross it out, and the answer would be no solution. Okay, so this is really important. All right, so that's example 1. Example 2 is very similar, except we have an extra step. No, we don't. We don't have an extra step. Okay, it's very similar because we have two things. So I need my LCD. So remember, we look at our denominators. In this case, can I turn one denominator into the other? Nope. So once again, which you'll find is the case for some, but not all problems, we take this x and we multiply it by the x squared minus 3. I can't do anything else. There's nothing else to deal with here because that's it. That's my LCD, right? I could turn both of those into this LCD. But instead, remember, we're going to multiply both sides by that LCD over 1. As long as we do the same thing to both sides, we're going to change the look, but not the value. On the left side, so I'll erase my highlighting now, the x's will simplify, and I distribute my 3. Please don't forget about the distributive property. 3x squared minus 9 equals. On the right side, the whole x squared minus 3 factor simplifies. So I get 2x times x, which is 2x squared. Okay, so I'm going to subtract 2x squared from both sides. And I'm also going to add 9, because I'm getting all the x's on one side, all the whole numbers on the other. Okay, so these simplified. So I'm left with 3x squared minus 2x squared, which is 1x squared, equaling positive 9. Okay, so you have to remember how to solve this. Don't forget, when we square root both sides, plus or minus. Square root both sides, plus or minus. That's something you always have to remember from now on within this class. So I get two solutions, 3 and -3. Actually, I'm not going to box them because we got to check our excluded values. So I go back to my original problem. I have my denominator here and here. So the first one is actually a really easy one. X cannot equal 0. That's my first excluded value. The other one, x squared minus 3 cannot equal 0. So that means x squared cannot equal 0. If we square root both sides, what do we, oops, made a mistake. I add 3 to both sides. So it's not 0, it's 3. When we square root both sides, remember plus or minus. So I get two more solutions that x cannot equal, which is the square root of 3 and the negative square root of 3. So we check those. I have normal 3 and -3, so we're good. If we had one of these solutions, we'd have to cross it out. Cannot, it's excluded. We cannot use it. Okay, so that's example 2. Example 3 seems like it's more complicated, but really it's not. We do the same thing. We look at each denominator separately, and we say, okay, what could we turn all of these into? Well, this one has a 2, this one has a 4, and this one has a 4. I can turn a 2 into a 4, and then the 4s are already 4s, so it's definitely a 4. This one has 1x, no x. So it looks like 1x, right? I can make this one, if I multiply the top and bottom by an x, make that. But instead of actually creating that, we're just going to multiply both sides by 4x over 1. One thing to remember is if I multiply this side by it, I have to multiply each piece by it. So I'm just going to write it every single piece, multiply by it, because you have to do the same thing to all the pieces on every side. So on this side, I'll erase my highlighting just to make it easier to see. On this side, the x's will simplify, and the 2 and the 4 simplify to just 2. And so I'm left with 2 times 1, which is 2, equals. On this side, the 4 and the x simplify, so I'm left with just 5, plus the 4 simplifies, so I'm left with 3 times x, which is 3x. Then I can just subtract 5 from both sides. It's a pretty simple thing now. Notice if you use this little skill of being able to pick out an LCD and multiply by it, you get rid of all the fractions, and it makes life so much easier. So I get -1 equals x. Okay? But I'm going to erase these things because we need to look at our denominators. Which of these can create 0? Well, 2x cannot equal 0, and 4x cannot equal 0. We'll notice something, though. If we divide by 2 or 4, it gives us the same excluded value. X cannot equal 0. Remember, the 4, there's no x there. So the 4 is just never going to be equal 0. So that's fine. It's just these ones with x's in them that we have to look at. So x can't equal 0, which we did not get as our solution, so we're good. Okay. Example 4. So we look at our LCD once again. So I look at my denominators. What could I turn these denominators in? Notice this doesn't have a denominator. You can put it over 1, which I would actually recommend if you need to help you out. But the denominator is just 1 in that case, which, I mean, you can just turn 1 into anything by multiplying by that thing. So we need to look at our numbers. We have a 2, a 1, and a 1. So that means 2 is the biggest number that they all relate to. We can turn a 1 into a 2 by multiplying by 2. And 2 is already 2. And I have 1x, no x, 1x. So 2x. I'm going to, multiply every piece by that. 2x over 1 times 2x over 1 times 2x over 1. Be careful about that minus sign. It's hard to read it after I put things. So that one, they both simplify, so I'm left with just 5. Equals, nothing simplifies here, so it's 34x minus, the x simplifies, so I get 6 times 2, which is 12. Okay, so I'm going to add 12 to both sides. Get the x by itself, so I get 17 equals 34x. Then I'm going to divide by 34 on both sides. This can simplify. 17 goes into 34 twice, so it's 1 over 2 equals x. And then don't forget, we have to check our excluded values. So we look at our denominators. Well, 2x and x are the ones that matter. The 1 will never equal 0. So 2x cannot equal 0, so x cannot equal 0, which we will get the same result from the other one. And notice 1/2 is not 0, so we're good. Okay. Example 5. Same thing. We look at our denominator. This one's kind of nice. They're already the same. So you can multiply both sides by your LCD of x plus 2, or if you understand how fractions work, as long as the tops are equal, then they will be the same. So we can just set the top equal, x minus 1 equaling the other one. But let's look at this real quick. So I'm going to do the same steps. X plus 2 over 1 times x plus 2 over 1, and they simplify. As long as we do the same thing to both sides, we're good. So I get x minus 1 equals x squared plus 2x minus 3. So it's been a little bit now, but this is a quadratic. To solve a quadratic, we did a whole unit on this, solving a quadratic, it has to equal 0. So I'm going to subtract x and add 1. So I get 0 equals x squared plus x minus 2. And then we factor So I get x plus 2, x minus 1, and then we solve. Set each one equal to 0. Running out of room here. So I'll move it over. So I set each thing equal to 0. So I get x equals negative 2, and x equals positive 1. So x equals negative 2 and positive 1. All right, then don't forget to check your excluded values. Go back to the original problem and look at your denominators, the bottom number. So x plus 2 cannot equal 0. That means x cannot equal negative 2. We have a problem. Can't equal negative 2, so that solution is thrown out. So x equals 1 is my only possible solution because it is excluded. Okay, number 6. More complicated, but following the same steps. X plus 1, x plus 4, and x plus 4. Those are my denominators. So my LCD, they are separate. I can't turn an x plus 4 into an x plus 1. So x plus 1 times x plus 4 is my LCD. So I'm going to have to multiply every piece by that, which you'll notice is actually a little difficult in some cases. The first two aren't too bad, so I'm going to multiply by x plus 1, x plus 4 over 1. This one's going to be hard to write in, but I'll just kind of write it in right here. X plus 4, x plus 1 all over 1. And this one is x plus 4, x plus 1 all over 1. So we take each one separately. This first one, the x plus 1s will simplify, so you got to distribute the x here. So it's x squared plus 4x. Don't forget the distributive property. Plus, the x plus 4 simplify, so I distribute the 3 here. It's 3x plus 3 equals, the x plus 4's, ooh, that's not going to be nice. I got to distribute this whole thing into this. So x times x is x squared, x times 1 is 1x, 3 times x is 3x, 3 times 1 is 3. Okay? It is, well, let me combine like terms. So I got x squared plus 7x plus 3 equals x squared plus 4x plus 3. It is technically a quadratic, so I need to make sure this equals 0. You'll notice something. Some of you have probably already seen it, but when we move, something happens. So when I make everything equal to 0, this whole side goes away. So I'm left with x squared minus x squared, which is 0. 7x minus 4x, which is 3x. 3 minus 3, which is also 0. So that's all I'm left with. And so when I solve for x, 0 divided by anything is 0. So x equals 0 seems to be my solution. But never just stop there. Look at your excluded values always. So x plus 1 cannot equal 0. So x cannot equal negative 1. And x plus 4 cannot equal 0. It's twice. I'm not going to do it twice. X cannot equal negative 4. But neither of those are my solution, so I'm good. X equals 0 is fine. Okay? All right, number 7 throws in some function notation. So we got to set up the equation first. So right here I get 2 over x plus 2, because that's f, equals x plus 2 minus 2 over x plus 2 plus 6. I'm just going to simplify real quick. So I get 2 over x plus 2 equals, this 2 minus 2 is 0, x over x plus 2 plus 6 over 1, just to help myself out for when I make my common denominators. So I check these things. My least common denominator, this one's easy because the only denominator that really matters is the x plus 2. The one, remember, we can turn 1 into anything. So I'm going to multiply everything by x plus 2 over 1. The first two, the x plus 2's simplify, so I'm left with 2 equals 6x plus, this one nothing simplifies, so I gotta distribute, 6x plus 12. I'm gonna subtract 12 from both sides. I get negative 10 equals 7x, and divide, and notice it's not a very nice number. That's okay. Negative 10 over 7 equals x. We gotta check our denominators, so x plus 2 is my only denominator, so x plus 2 cannot equal 0, so x cannot equal negative 2. That is not negative 10 over 7, so we're good. That is my solution. Don't expect them to always be super nice numbers. They can be other things. Okay? Example 8. So we're going to have to factor. First, whenever you have denominators that can factor, you need to factor them. So x plus 5, x plus 2, and you'll notice something here. When we look at our denominators to find the LCD, you'll notice that they have things in common, right? So my LCD then is the x plus 5, x plus 2. Because that's the same. This one I have to multiply top and bottom by x plus 5, this one by x plus 2 to make it. But remember, we're not going to do that. We're going to multiply every piece by our denominator, LCD, and clear the fractions, because that makes life so much easier. As long as we do the same thing to both sides, we're good. So this one, the x plus 2 simplifies, so I got to distribute x squared plus 5x. This one, they both simplify, so it's just plus 3 equals x plus 5 simplifies, so I got to distribute the 3, so I get 3x plus 6. It's quadratic. We got to make it equal 0. Whenever it's quadratic, it has to equal 0. So I end up with x squared plus 2x minus 3 equals 0. Okay. To do this, we got to factor. So I get x plus 3, x minus 1. That's what it factors to. So x plus 3 equals 0, and x minus 1 equals 0. So x equals negative 3 and positive 1. Now then, check your factors. So x plus 2 cannot equal 0, so x cannot equal negative 2. And x plus 5 cannot equal 0, so x cannot equal negative 5. So we're good. None of those match our excluded values, so we have two solutions. You can have no solution, two solutions, one solution, however many solutions ends up. Okay, if everything gets crossed out because they're all excluded, that just means you have no solution. That's okay. All right, example 9, f minus g. So just set it up, f minus g equals 0. You should always have in these problems an equal sign. If you have an equal sign, that is when you solve. If you don't, that is when we just simplify. That's what we've been doing before this. So this one can factor, so I'm going to do that. Okay. So we look at our LCD. X plus 2, x minus 2 seems to be my LCD. That one is already that. This one I can multiply by x minus 2 to get to that. But remember, we're going to multiply everything by our LCD on both sides so that we get rid of the fractions and make life a lot easier. Okay, so the first one, x plus 2 simplifies, distribute the 4, 4x minus 8. The second one, both simplify, minus 6. Equals 0 times anything is 0. Doesn't matter that it's a whole bunch of crazy values, just 0. So combine 4x minus 14 equals 0. I'm going to add 14 to both sides. And I get 4x equals 14. Divide by 4 on both sides. Simplifies some, but not all the way. 2 goes into both, so 7 over 2. Before we do anything, check our excluded values. X plus 2 cannot equal 0, so x cannot equal negative 2. And x minus 2 cannot equal 0, so x cannot equal positive 2, which doesn't match, so we're good. Okay. That was a little bit longer of a note, but there's a lot of things here that we have. It's the same steps, but a lot of little tricks throughout. So make sure you answer your essential question in your 3-sentence summary.